Hi, welcome to videomathlessons.com, and tonight we're going to be looking at a Math 12 pre-calculus lesson. Our topic tonight will be, we're going to be talking about functions and the graphs, but more specifically, we're really going to be talking about how to find the zeros or the roots of a polynomial function. So let's jump right into it. So if I give you a function, if I say f of x equals x cubed plus x squared plus x plus 1, in the past, in Algebra 2, how you would go about this, if we said, oh, how would you find the roots? You might say, hey, look, why don't we factor? And this is a grouping, factor by grouping question. And actually, it would work a little bit. You know, you would actually get something out of this thing. Unfortunately, the problem's going to get harder than that. So I actually could do this by grouping, but we're going to look at how we're going to do it now this year in Math 12. All right, so now we have a bunch of things that you've learned, or if you haven't learned, you're going to pick up on them right now. We've learned things called Descartes' rule of signs. And what that does, it talks about if the sign changes in the polynomial function, that would tell us what type of roots you're going to have, what type of real roots you're going to have. So they can be positive, negative. We've also talked about the rational root theorem. And the rational root theorem will tell us what are the possible roots, what possible real roots I would have. And we do that by factoring. We'll do that in a second. Rational root theorem. We have the remainder theorem. This is good because it's a shortcut. You can get around not using it, but it's pretty good. So it's the remainder theorem. We have synthetic division, which is going to be important because synthetic division is going to allow us to, once we find the roots, take out the roots and come up with new equations to break down even further. So we have synthetic division. And the last one we're going to think about is to actually find the, to break down after synthetic division. We could do a little bit of shortcuts. Or if they're imaginaries or irrationals, we're going to have to use the quadratic formula. Or completing the square. So let's get started with this. So there's a lot of stuff that we can do. Now, you've moved along in your math career here, and you've learned quite a few things, and we'll start using some of these. In actuality, for this problem, we really don't need Descartes' rule of signs because I'm actually not going to graph this one, but it helps actually to graph, or it's good just to keep in mind what things are going on. So let's take a look at Descartes. Descartes' rule of sign says, look at the function regular f of x, and if there's a sign change, that's a possible. It's not possible. It's a positive roots. So let's take a look at sign changes. It's to be how many. So we start off here. This is positive always, right? To start with, if it's not listed. So what we got here is there are no sign changes. So I know flat out there are no positive roots. Well, let's do the negative now. Now it says, well, listen, if you plug in negative x into this problem, okay, so I'm going to do negative x cubed plus negative x squared plus negative x. And it says if you evaluate this now, that would tell us how many negative roots we can have. So now let's do this. Now, negative, and it's really not that bad actually, because if you have an odd power, you get whatever sign you started with. So if it was negative to start with, it'll stay negative when I get done with an odd power. Evens turn positive. So if this is plus this, it'd be plus positive x squared minus x plus a 1. So now I look at the sign changes now. So now let's look at sign changes. Now I got negative now to start. So I got 1 change, 2 change, 3 changes. So I could have 3 negative roots. Unless some are imaginary. Now, if they're imaginary, those always would happen to conjugate pairs. So what they would do is you subtract off pairs off of this. So it would be 3 or 1 negative root. So if I start out with 5, it'd be 5, 3, or 1. So that's my thing. So that's from Descartes. So we use Descartes. That one's done. Now let's do the rational root theorem. Now remember, we're back here at the original here. Back at the original. So let's take a look at let's look at this now. All right. Rational root theorem. Rational root theorem says this. What are the possible roots you have? All right. So now what they say is you're going to factor the back and put it over the factors of the front, the coefficient. Now remember, if you don't see something, there's a 1 to start with. So the rational root theorem, okay, we'll say factors of 1. Well, it's not many factors of 1, so it's plus minus 1, because it would be positive, positive 1, or negative, negative 1 to make a 1. And then factors of the front. Well, once again, it's just plus minus 1. And so when I actually do this, 1 over 1 is still plus minus a 1. Now, I'm going to use, so rational root theorem, check, done. Now I'm going to use the remainder theorem. I need to know which one of these is going to be in my function, which is a root. Well, guess what? We already did Descartes, and Descartes says this, yo, there's no positive roots in here. So I would not pick the positive one. So that's actually, helpful to know. So I'm going to try the negative one. So I'm going to use the remainder theorem now. All right, now that I got the remainder theorem. And the remainder theorem says this. If I plug it in, if I get negative, if I get a 0, that means the remainder is 0, which would make that negative 1 a root. So I'm just going to plug it in and see what happens. Now, for this problem, I really don't need to do this step. If I had a bunch of numbers to choose from, like 1s and 3s, 2s and 5s and stuff like that, then this would actually be a helpful step because it just narrows down what I want to work with in synthetic division. I really don't have that many choices, so it's not that big a deal for this problem, but for further problems, that actually would be, kind of important. So let's look at this. This cube, we already said that would stay negative 1. That becomes positive, negative 1, positive. So that makes a 0. I know negative 1 is a root. Negative 1 is a root. So I already know that. All right, so now, once you know it's a root, what are you going to do? So let's take a look. I'm going to use now, so remainder theorem, check. So let's go to synthetic. So we go to synthetic division. So now I'm going to set up a synthetic division. I know negative 1's a root, so I'm going to put negative 1 outside the box. And I'm going to take the coefficients off our original. And they're all 1, so that's pretty easy. So I got a 1, 2, 3, 4. 4 terms. And that's my, so I'm going to do a synthetic division. And if you recall, the first number comes all the way down straight. And then you just do what it says. You multiply. Negative 1 times 1 is negative 1. Clean it up. You get a 0. Multiply, you get a 0. Bring it down, do what it says, combine it. Multiply, negative 1, this is 0. The back number is my remainder. I know the remainder was going to be 0 because I did it up here in the remainder theorem. So these are my coefficients for my new equation. If we start with x cubed, this b1 would be a coefficient for x. It would be x squared, 1x squared, plus 0x, there's no x, plus a 1. That's my new equation. We're going to break this down now and to get the final roots. Now, I'm not going to do synthetic division on this because actually I used up all my choices. So now I know from this, I know it's imaginary, but like if you didn't know, you'd be like, I don't know what this is. You would do the quadratic formula or complete the square. So let's take a look. So synthetic division, done. Well, if they actually said, can you write this in factored form? My original, it would look like this. X, so it would be f of x equals, well, I already did x minus, I got the negative 1 here. So if I put that back in the parentheses, it would be x plus 1. And then I got this x squared plus 1. So that would be factored form. I want to find the roots for this problem. So I'm going to keep on going with this problem. So let's try this. Let's finish this up. So now, once again, I have this. I have f of x equals x cubed plus x squared plus x plus a 1. I don't know what that is. That's all banged up. So I'm just going to rewrite our function that we had to start with so we can see what we did. I already know I can break this down. If I said factored form, it would look like this: x plus 1 times x squared plus 1. All right, but I want to find the roots now. So I used Descartes' rule of sign to figure out what type of roots I could have. I used rational root theorem to figure out what the numbers could possibly be. I used remainder theorem to figure out which root what it was. Synthetic division to break down and get the simpler equation. And now we're at the last stages. I want to break down this x squared plus 1. There's two ways to do it. If you want, I could just set it to 0 and just look at it. And I say, all right, well, I could do quadratic formula, complete the square. I'll do, I don't know, quadratic formula. So I know the quadratic formula is x equals negative b plus minus square root b squared minus 4ac all over 2a. The a value is 1, b is 0, and c is 1. And so I just plug in these values. So I get, 0 plus minus radical 0 squared minus 4 times 1 times 1 all over 2 times 1, which is a 2. This cleans up. I get plus minus radical negative 4 all over 2. Square root of negative 4 is 2i. And don't forget, I still got a plus minus. And divide by 2. So my final answer is x equals plus minus I. Those are my last two roots. Now remember, this is a third degree polynomial, power 3. So it's telling me I'm going to have 3 roots. I have one real root. I have a real root of negative 1. And I have 2 imaginary roots. Plus minus I. So if they ask, what are the roots? Here they are. All one shot. It'd be negative 1, comma. I would just leave them together, plus minus I. Those are the roots. That's pretty good. Well, thanks a lot. Video math lessons. If you have any other questions, feel free. You can just send me an email. Just ask me about which ones you want to do. And actually, I'll do a part 2 for this problem a little bit harder. Good night.